Hi everyone, I'm T. Ramesh, Assistant Professor, Department of Mathematics, Dr. SNS, Rajalakshmi College of Arts and Science. In this lecture series video, we are going to discuss about the application of queuing theory to the bank ATM. So queuing is a common activity of customers or people to avail the desired service, which could be processed or distributed one at a time. Bank ATMs would avoid losing their customers due to a long wait on the line. The bank initially provides one ATM in every branch, but one ATM would not serve a purpose when customers withdraw to use ATM and try to use another bank ATM. Thus, the service time needs to be improved to maintain the customers. So the queuing theory used to solve this problem. We obtained the data from the bank ATM in a city. Then we derived the arrival rate, service rate, utilization rate, waiting time in the queue, and the average time of number of customers in the queue based on the data using Little theorem and MM1 queuing model. The arrival rate at a bank ATM on Sunday during bank time is 1 customer per minute. That we call it as it is CPM. While the service rate is 1.5 CPM. The average number of customers in the ATM is 2 and the utilization period is 0.70. So we conclude this by discussing the benefits of performing queuing analysis to a busy ATM. Okay, now we are going to go into the process. First, we are analyzing what is consider the queuing system. So consider the queuing theory to study the waiting lines in ABC Bank ATM at Gandhipuram, Coimbatore. The bank provides one ATM in every branch. In ATM bank, customers arrive randomly and the service time is also randomly. We use Little theorem and MM1 queuing model to derive the arrival rate, service rate, utilization rate, waiting time in the queue. On average, 600 customers are served on weekdays, that means Sunday to Thursday, and 300 customers are served on weekdays, that is Friday and Saturday monthly. Generally on Sundays, there are more customers coming to ATM during 10 a.m. to 6 p.m. Right. So the arrival rate at the bank ATM on Sunday during banking time is 1 customer per minute. That is already we take that it is a CPM. While the service rate is 1.5 customers per minute. The average number of customers in the ATM is 2 and the utilization period is 0.70. So we are discussing the benefit of performing queuing analysis to busy ATM. Right. ATM model, MM1 queuing model. Here we apply a lot of formulas. In MM1 model, queuing model means the arrival rate and the service rate exponentially distributed Poisson process. That means analyzing the ATM. So the MM1 queuing model, the following variables we investigated. Lambda, the mean customers arrival rate. Mu is the mean service rate and the utilization factor is nothing. It is rho is equal to lambda by mu. So probability for 0 customer in the system. So how we calculate this? Before that, the probability for n customer in the system is Pn, that is equal to rho power n into 1 minus rho. Suppose if n is equal to 0, the probability of 0 customer in the ATM. That means P0 is equal to 1 minus rho. And rho power 0 is automatically anything power 0 is 1. Therefore, we get P0 is 1 minus rho. Now, the average number of customers in the system. That means in the system means here it is ATM. That is rho divided by 1 minus rho. And the average number of customers in the queue is rho square divided by 1 minus rho. And the next is the average waiting time in the queue is 1 divided by mu minus lambda. And the average time spent in the ATM, that is including waiting time, is rho divided by mu minus lambda. Okay. So now observations and discussions. We have collected 1 month daily customers data by observing during the bank time as shown in the table. So weekdays, first week, second week, third week, fourth week. In first week and weekdays Saturday to Friday. So we take all the days. And the weekdays first week, the Saturday is 70 peoples and Sunday 191 peoples, Monday 161 peoples, Tuesday 120 peoples, Wednesday 130 peoples, and Thursday 111 peoples, Friday 95 peoples. Likewise, second week Saturday to Friday, third week Saturday to Friday, and the fourth week Saturday to Friday. We calculate all that. These are all total number of customers. But among all these informations from the table, we observed. So all this consideration, we observed that the number of customers on Sunday is double the number of customers on Saturday during the month. The busiest period for bank ATM is Sunday and Monday during bank time. That is, bank time duration is 10 a.m. to 6 p.m. Hence, the time period is very important for the research, for our conclusions. Also, we observed from the figure, the table, after Sundays, the number of customers start decreasing slowly as the week progresses. On Saturday, it is least, and the Thursday and Friday, it says slightly more than the Saturdays. This is because of Friday and the Saturday will be a holiday. We consider that, we take that. And next, the service mechanism or the service pattern. Conclusions here, calculations we take. We investigate that after Saturday, during first 2 days of a week, there are on average 60 people coming to the ATM in an hour time, period of banking time. From this, we can derive the arrival rate as 60 divided by 60 is equal to 1 customer per minute, CPM. Customer per minute. So we also found out from observations and discussions with got that each customer spends 2 minutes on average on the ATM. The queue length is around 3 peoples on average, and the average waiting time is around 2.5 minutes, that is 150 seconds. Okay. Now, we shall calculate the average number of people in the ATM, that is equal to 1 customer per minute into 2 minutes is equal to 2 customers. The average number of customers in the ATM is, we can derive the service rate, and the utilization factor is 1.5 customers per minute. That means the utilization factor is lambda by mu. So already we calculated the lambda, the number of customer service, 1 customer per minute. Therefore, it is 1 divided by mu is utilization is 1.5 customers per minute. Therefore, 1 divided by 1.5 is equal to 0.7. With a very high utilization rate is 0.7 during the bank time, the probability of 0 customers in the ATM is very small, as can derive P0. So that is 0 customers. And none of the customers in the ATM is 1 minus rho, that is 1 minus 0.7 is equal to 0.3. The queuing theory provides a formula to calculate providing probability of having n customers in the ATM as follows is rho power n. Already we calculated, we know the formula is Pn is equal to rho power n into 1 minus rho. So that is equal to 0.30 into 0.7 whole power n. So we take that. So we assume the impatient customer will start to bank when they see more than 3 people are already queuing for the ATM. We also assume that the maximum queue length that a patient customers can tolerate is 10 people. As the capacity of the ATM is 1 people, we can calculate the probability of 4 people in the system, that is in the ATM. Evaluations, the utilization is directly proportional to the mean number of customers. It means that the mean number of customers will increase, the utilization increase. The utilization rate at the ATM is very high, 0.7. This, however, is only the utilization rate during the bank time is on Sunday and Monday. On weekend, the utilization rate is almost half of it. Yes. So this is because the number of customers on weekdays is 1/2 of the number of peoples on weekdays. So this because the number of customers on weekdays is only half of the number of customers on the weekdays. Okay. So in case the customers waiting time is lower, or in other words, we waited for less than 150 seconds, the number of customers that are able to serve per minute will increase. When the service rate is higher, the utilization will be lower, which makes the probability of the customers going away decreases. So we conclude all these things. So from the result, we have obtained that the rate at which customers arrive in the queuing system is 1 customer per minute, and the service rate is 1.5 customers per minute. The probability of a buffer flow, if there are 3 or more customers in the queue, is 10 out of 100 customers. So the probability of buffer flow is a probability that the customers will run away because maybe they are patient or impatient. Mainly it is impatient to wait in the queue. Thank you.